Alright, for this problem, you guys, I want to find the particle moving to the left. To find out where a particle is moving to the left, that means I want to know where my velocity is negative. To find out where my velocity is negative, well, that's my function, right? So don't you first want to find out where it's 0? Now, that's a little tough without a calculator, but you have to be able to do this without a calculator. They found at these 2 points, it's 0. And then don't you just plug in values somewhere between 0 and 3, say 1. You probably plug 1 in. And then 4. And then don't you have to try a number on the other side of 9? Because my interval goes to 12, right? So don't you try things between 0 and 3, 3 and 9, and 9 and beyond. You try all those, and what you'll notice is the particle is moving less when the velocity is negative. And you will notice that your velocity is negative on this interval. Okay, so make sure you would show a little bit. They didn't show much work here. They do have the key ideas, but they didn't show much work. You might want to make one of these little charts. Do not use this as a justification, but I would probably do a 3 and 9 and 12 and 0. And what you'd catch on to, wasn't this negative for velocity? And these two, I guess, would end up being positive if you checked it. That is not a justification. You are not allowed that. But this helps visually to help you on the problem. For this one, it says, set up but do not evaluate the total distance traveled from 0 to 6. Be careful at 0 to 6. Some people put a 12 because they think for the whole thing. They won't pay attention to the interval they give you. The reason they're not telling you to solve it is this is a non-calculator. They don't want to waste your time. They just want you to kind of set it up, make sure you can do that. So if you look at the answer, if I want distance, you deal with the integral velocity, because you want position, but it has an absolute value. Because for absolute value is important, because what happens is if you visualize this, do you understand if you're walking this way, but then all of a sudden you've walked back, and then you go this way? Okay, if you're walking, then you come back, then you go back again. If I didn't do the absolute value of velocity, wouldn't this negative be taken away by my velocity? And thus, I want to get my total distance traveled. Because this is all movement. I'd have to add up all those segments together for total distance. Where if you didn't have the absolute value, you would only have the distance from this point to this point. You'd miss that coming back and back. So a whole bunch would be negated from itself. So be very careful that you have an absolute value when you hear of total distance traveled. The next one here, acceleration of the particle. That's pretty easy. So if I want the acceleration, don't you just do this right here? Wait, where did they get the acceleration equation? Didn't you derive that? Take the derivative of that? And if I want the acceleration, where's the problem? At 4. Oh, no, time t. It doesn't say where, huh? It just wants to find the acceleration of the particle at time t. Is that done? Yeah, that's an easy question. Is the speed, that's very important. Speed is the absolute value of velocity. Speed is the absolute value of velocity. That's very important. Very, very important. And I want to know if it's increasing, decreasing, or neither at 4. Explain your reasoning. So to find speed of the particle increasing or decreasing, watch this. Here's how they explain it. All right. They explain it by finding the acceleration at time 4 and the velocity at time 4. And they noticed each of them are negative. And then so they said, since the signs are the same, I know it's increasing. I would know this. This is a shortcut way of explaining it. Otherwise, the way I'm going to explain it right now is kind of complicated. But I'm going to give you the reasoning behind why this is the case. Why is this true is important. But in the end, if the signs are the same, it's increasing. If the signs are different, decreasing. That's what you need to memorize. For speed, speed. So here's why it is here's why that is the case. If my velocity is negative, and I'm talking about speed, isn't that going to mean, here's my graph, doesn't that mean if I have a graph like this, isn't this graph right here for velocity going to get flipped over for speed? Got it? So it was a slope that's negative, right? A value that's negative, isn't that going to be flipped over and now is it positive? So what was a negative slope is now a positive slope. So it is a negative slope. Sorry, I got that wrong. I pointed the wrong one. Here, isn't this your acceleration is the slope of velocity? So it is a negative slope. Isn't that a negative slope, blue line right there? Isn't it now a positive slope? So it's the opposite of that. So that's why if the signs are the same, it's always going to be increasing. All right. Now, if I was talking about a point right there, does it get flipped over? No. So if it's positive, is it going to stay positive? If it's negative, sorry, if it was negative here, won't it get flipped over and be going down? Okay, if it was here, I have a line like that, when it gets flipped over, it's going down. So if that was positive and that was negative, sorry, it's kind of complicated. Hopefully this helps understand why it is the way it is. Now, if I want to find the position of the particle at time 4, to find position, you have to first find out where you started and then sum up the change. It's a pretty important concept. So what we're going to do here, if we look right here, there's the answer right here. So to find the position x4, I first need to start at -2. That's my position at time 0. It's in the problem at the top. Then you sum from 0 to 4. You do the integral from 0 to 4 of the function, and then they had to do it by hand. Okay, if you had a calculator, this would be very quick and easy. But position, you have to do your initial and sum up the change. There is no absolute value here. This is where the absolute value is not important. If you have total distance, you'd want absolute value around this. But this is the change of what's happening. So if you start at -2, you could have gone this way, then you could have turned around, then you could have done this, and then you could have turned around. You could be right here at the end. I don't know what's happening. But this right here does all of this for you. It figures out where you're at, all the back forth. It does all the calculations and stuff for you.